here we go. So hello to everyone. So today I will present you a project that we have done with Savoir-faire Linux, which was integrate Jami in Yokto and run it on an i.MX6, and more particularly on a Toradex Apalis i.MX6. So I entitled it How to Bring Fully Distributed and Secure Communication Capabilities to Embedded Products and IoT. So because, well, Jami is focused on communication security, and we think that this security is very important in today's IoT and embedded products communications. So, well, before starting, a little word about me. So I am Kevin L'Hôpital. I am a junior embedded engineer at Savoir-faire Linux. And I'm basically working on creating custom Yocto BSPs and also working on medias and doing job like, well, camera integration and also working on my CSI. Savoir-faire Linux is based in Montreal, in Canada, and also in Rennes, in France. And we are working for different clients on open source softwares in multiple sectors. So, well, I will start with a little presentation of Jami and, well, why we wanted to do this project. Then I will, continue with the presentation of our work, so the Yokto integration, and the run on the i.MX6. And I will finish with a little demonstration. Well, let's start with the Jami presentation. So Jami is a communication tool developed by Savoir-faire Linux. It is available for Windows, macOS, standard Linux distribution like Ubuntu or Fedora, and also on smartphones like Android and iOS. So Jami is a free and open source audio, video, and text peer-to-peer communication platform. It does not require a server and implements a distributed and secure end-to-end encrypted communications. Moreover, this distributed architecture offers private life protection on the internet. So Jami can be used by mainstream users as well as professional. And recently, Jami has implemented some new and interesting features. Well, one of the main is the video conferencing that you can see here. Well, it allows you to be a large group of participants in the same call. The second one is the possibility to create rendezvous points. And these are accounts that can be called at any time, even if the creator is absent or in another call, sorry. And to finish, Jami's team developed a Jami account management server called Jams, and Jams allows you to create and manage your own community of Jami user. So, well, let's continue with why adding Jami in the embedded board and why we have done this project. So, adding Jami on an embedded board creates the possibility to have a secure communication and private life protection on all kinds of devices. Well, you all know that in today's world, more and more objects are connected to the internet, and the technology called IoT, for Internet of Things, is growing. These new multimedia communication are, well, not confined to smartphones and laptops, but are new use in personal assistant, connecting rebels, baby phone, and much more. And these are everyday life objects and also private life objects. So the security of their communication is very important for our private life. So we think that Jami fits into this objective with its serverless, distributed, and secure end-to-end encrypted communications. We could also think about a network of CCTV, a mesh of large volume of sensors, a fleet of robots, etc., etc. There is a lot of applications that we could think of. For example, thanks to Jami's distributed architecture, it allows you to manage a large volume of sensors, exchanging data in a secure environment. But well, another reason why we consider adding Jami on an embedded device is because nowadays the embedded resources have notably increased, and they now include hardware codecs and are being able to run Jami without too much CPU consumption. Nevertheless, we were not sure if Jami could run on the i.MX6, and that is why we have done some tests before starting the project. So first, to be sure that we could run a Qt application, we added a cinematic experience, which is a Qt5 demo application, and we were able to run it with less than 10% of CPU. In order to get closer to the final usage and evaluate the performance of the i.MX6, we have done some tests with and without these hardware codecs. We have streamed a camera of a resolution of 800 by 600 over the network after encoding it in H.264. And the result was, without hardware acceleration, we got a CPU percentage of around 90% and a reception of almost 0 frame. But well, with the hardware acceleration, we reached CPU percentage of around 7% and no loss of frames. So we can see with these results that we could imagine run Jami on an i.MX6. But well, it was still a challenge because we still need to control all the chain in order to have a good performance. And this is why we choose to integrate Jami in Yokto. So let's now switch to, well, the presentation of our work and the Yokto integration. So the Yocto project is a Linux Foundation project and an open source collaboration project. It helps you to produce custom Linux distribution for, well, multiple platforms. Yocto is using cross-compilation to easily export the generated distribution to multiple architectures. Yocto is based on a reference distribution named Poki, and then it gives the freedom to take layers already created, but also to make your own. The goal of these layers is to, well, include or customize any features you want in your final distribution. Each layer contains recipes which describe what you want to install in your Linux image. And finally, Bitbake, the building tool of Yocto, will then generate a Linux image ready to be flashed on your embedded device according to the content of your recipes. Embedded boards have limited resources in terms of energy, in terms of memory, and also in terms of pure hardware. I mean CPU and GPU, etc. And that's why Yocto is very interesting, because you can control everything that will finally run on your embedded device. Another thing that is interesting in Yocto is that the board makers are mainly providing a layer to support their board. So, well, after presenting the Yocto project, let's now talk about the integration of Jami in Yocto. So the goal was to, well, integrate Jami in Yocto without significant Jami source code modifications, in order to easily integrate any updates and also not to, well, stray too far from the original source code that could generate lots of source code maintenance for the embedded part. And at the end, the goal was to be able to, well, create an account and call any other Jami user as if you were on your standard Linux distribution. We tested our work on the Toradex Apalis i.MX6, and running Jami on such embedded boards opened the opportunity to run it on other embedded boards and on every platform supported by Yokto. And this could be easily possible because Yokto is very modular, and as I said before, it is organized in a layer system. So the already created layer could be reused as a base for other platforms. And well, that's why we have cut our work in multiple layers to fit in this Yokto philosophy. So, well, here is a diagram that represents our work. So we created 3 layers. The first one, called Jami, is wrapping the application and all its dependencies. The layer is providing the graphical application of Jami that includes the backend daemon and the multi-platform Qt client. It is providing Jami for x86 architecture, and it contains the same source code as a standard Linux distribution. And well, as I was talking just before, this layer will also be the base to, well, export Jami for other architectures. Therefore, we created a second layer called Jami i.MX that is based on the previously created Jami layer. This layer is providing Jami for the i.MX6 and is containing an Fmpeg work that I will present you just after with a library that we have used, and also the only source code Jami source code modification that we have made. This layer could be also reused to export Jami to another i.MX6 embedded board. And the last layer that we have created is Jami i.MX Toradex, because the main purpose of our work was to run Jami on the Toradex Apalis i.MX6. So consequently, we created a layer that provides a machine, a distro, and an image that include Jami to run on the Apalis i.MX6. So this layer is a layer ready to use. I mean, there is no more modification to add to run Jami on the Toradex Apalis i.MX6. As you see, we have used a Toradex kernel based on Freescale 1, but we could easily imagine using a mainline kernel, and it is a work that we are planning to do. The choice to run on a Toradex kernel is because, many companies are using the boardmaker kernel, but the plan is to use both kernels. I was talking about an Fmpeg work that we have used in the i.MX6 layer. So Fmpeg is a cross-platform tool used to record, convert, and stream audio and video. Fmpeg libraries are, for example, used in the famous media player VLC. So in order to perform a call, we need to use the hardware encoders and decoders present on the board instead of software ones. Without hardware acceleration, all video encoding and decoding operations are executed on the CPU. And you all know that video compression and decompression are very complex algorithms that generally cannot be executed in real time on the CPU, as we demonstrated in our test that I presented you earlier. So therefore, using software codecs would make Jami unusable. And well, Jami is based on Fmpeg, and it doesn't support i.MX hardware codecs for a free-scale kernel, I mean. And that's why we applied some patches to Fmpeg to include these codecs. So we added an H.264 encoder and decoder for sending and receiving video, as well as MJPEG decoder to support some camera output formats. In order to add them, we based our work on the community API libre i.MX VPU API that provides the control of the i.MX VPUs. This API is already used in GStreamer i.MX. In addition, the only Jami source code modification that we made is to use the hardware encoders and decoder of the i.MX6, and so we reached our objective, which was to have the less Jami source code modifications to run it on the embedded board. So let's now switch to the demonstration. So in this demonstration, I will show you our work on the Apalis i.MX6, and I will say also a little word about the performances and the work that is still to be done, because it is a proof of concept, and we wanted to show that it is possible to run Jami on an embedded board, but there are still a bit of work to have a clean working Jami on the i.MX6. So I'm going to switch to the Toradex Apalis. So you can see here, if I put, all right. So you can see here at the right the Apalis i.MX6 with Jami, and at the top left it is my my Jami on my computer. So I will call the Apalis i.MX6. So you can see that we receive the call. I will answer. All right. So if I can show you here that there is a quite good latency. It's not easy to show you that, and on the other side also. So we can call from my PC, but we can call also from the Toradex Apalis also, and I can answer on my PC also. So I'm doing in local, but it's the same if we wanted to call someone else. It's just more practical to do it like this. I will not try to of course the audio is also working, but I will not try to show you, because I don't want to have a big echo in it will be very bad. So okay. I wanted to show you also the performances. So I don't know if you can see, but I will show you the performances here in live. So the Qt application is 21% consumption, CPU consumption, and the backend daemon is 18% CPU. So that's quite good, but we want to do better, and I wanted to talk about the work still to be done. So that's a work that we want to improve the performance, because, well, we have some format change that is still done in software, and we want to do all this in hardware. And of course, also the mainline kernel support. Well, I finished with my presentation. Well, if you have some question, I will be happy to answer you. All right, so let's switch to this. All right, okay. Let me just see the chat here if there is any question. I don't see anything, but well. But well, if you have any question, well, please don't hesitate to send me a mail. And thank you, Joe. And well, I will be pleased to answer your mail if you have any future question. Well, I have attached my presentation just under the live if you want to watch it again. And well, all the work is of course available on our GitHub at github.com / Savoir-faire Linux. You will see our 3 created layers. So, well, thank you for listening. Thank you for being here. And well, see you.